In this video, we're going to consider an equation, a radical equation, that has two radicals. Remember, a radical is a root, and you will be seeing that sign in your equation. Although in this time, we're going to be seeing it twice. For example, x minus 54, all under the radical, plus the square root of x equals 9. In the last video, we saw that the key is to isolate the radical. But what do you do when you have two radicals? When you have two radicals, you isolate the one that is more complicated. So we're going to isolate this one by subtracting the square root of x from each side. Remember, in algebra, as long as we're doing the same thing to each side of the equation, we're not changing the value of the variables. We're only changing the form of the equation. So now this gives us the square root of x minus 54 equals 9 minus the square root of x. The next step is the same as if we only had one radical, and that is that we square both sides. When we square the left side, we're simply going to be getting rid of the root, and we'll only be left with x minus 54. But when we square the right side, we're going to be left with a little more than that. Because we have to, squaring that means multiplying it by itself. That's the equivalent expression to squaring 9 minus the square root of x. So first we're going to do 9 times 9 is 81. Minus 9 square roots of x, and then again minus 9 square roots of x, so minus 18 square roots of x, and then finally minus square root of x times minus square root of x, which is plus the square root of x squared plus x. So what happened, almost as if by magic, is that we have x on both sides of the equation. So we can subtract x from both sides of the equation, and presto changeo, we now have a radical, an equation with a radical with only one radical. So I see a negative 18 square roots of x here, so I'm going to put that on this side. I'm going to add 18 square roots of x to both sides. So that will move that over there, and it'll get rid of it on that side. And then I see a minus 54 here, so I'm going to add 54 to both sides, and that gives me 135. So 18 square roots of x equals 135. I'm going to leave the original equation up there. And we're now at this point, 18 square roots of x equals 135. And so at this point, we would like to isolate the radical. The square root of x equals 135 divided by 18. Which is equal to 15 divided by 2. So we're going to square both sides. Again, when you square a square root, you're just left with whatever was under the radical sign, equals 15 squared is 225, and 2 squared is 4. So we now have a solution to our equation. For this equation, we are proposing that x equals 225 divided by 4. So the next logical step would be to put 225 divided by 4 back into the equation and see if it makes the equation true. So we have the square root of 225 divided by 4 minus 54 divided by 1 plus the square root of 225 divided by 4 equals 9. We've already seen that 225 is 15 squared and 4 is 2 squared, so we already know, but I'm going to move it over a little bit to give myself room to work. We already know that the square root of this is going to be 15 halves, and 9 is not going to change. So we need to deal with this. So under this radical, we've got 225, and then we've got to put everything under the same common denominator, which will be 4. We don't need to multiply this by 4 because it's already divided by 4, but we need to multiply 54 by 4 divided by 4 to put it under the same denominator. So there's the denominator. And so I'm going to multiply 4 times 4 is 16, 4 times 5 is 20, and 1 is 21. So this works out to the square root of 225 minus 216 divided by 4, and I left myself plenty of space. So we have the square root of 225 minus 216 would be the square root of 9/4, make sure that goes, plus 15 halves equals 9. That's our question. Well, 9 and 4 are both conveniently enough, both perfect squares. So let me just make a 10-10. So that's going to be 3 halves plus 15 halves equals 18 halves, which does in fact equal 9. And so we have solved our equation for x and gotten a value of 225 divided by 4, and then we've plugged that back into the equation, and with the result that it does in fact make the equation true.